In this video, we're diving into the essentials of evaluating language model outputs using Python metrics. You'll gain skills to assess accuracy and quality of LLM-generated content with practical Python applications. Did you know that the outputs of language models are transforming industries across the globe? From generating creative content to providing customer support, LLMs are everywhere. But how do we ensure these outputs are accurate and reliable? Today, we'll explore Python metrics for evaluating LLM outputs, a critical skill for professionals aiming to maintain high-quality AI content. Let's dive in.
Language models, or LLMs, are powerful AI tools designed to understand and generate human-like text. They're built on complex algorithms and vast datasets, enabling them to predict and generate words, sentences, and even entire articles. Examples include OpenAI's GPT-3, Google's BERT. These models are revolutionizing sectors like healthcare, finance, and entertainment by automating tasks and providing intelligent insights. However, the true challenge lies in ensuring that the outputs are not only accurate but also contextually relevant and ethical. This is where evaluation metrics come into play.
Evaluating LLM outputs efficiently requires a robust set of metrics. Python, with its rich ecosystem of libraries, offers a wide array of metrics to assess different aspects of LLM outputs. These metrics help in measuring accuracy, precision, recall, and more, providing insights into the performance and quality of the generated content. We'll explore tools like NLTK, scikit-learn, and TextBlob, which make it easier to implement these metrics. Setting up a Python environment with these libraries is your first step towards mastering LLM evaluation. Precision, recall, and F1 score are fundamental metrics in evaluating LLM outputs. Precision measures how many of the predicted positive observations are actually correct, while recall assesses how many of the actual positives are captured by the model. The F1 score is the harmonic mean of precision and recall, providing a balance between the two. Using Python's scikit-learn library, we can easily calculate these metrics. For instance, if you're evaluating a text classification model, you can use the classification_report from sklearn to get these scores and interpret how well your model is performing.
The BLEU score, or bilingual evaluation under study, is a metric used to evaluate the quality of text generated by LLMs. It compares the n-grams of the generated text to a reference text, providing a score that indicates how similar they are. In Python, you can use the NLTK library to calculate BLEU scores. For example, when evaluating a machine translation model, BLEU helps in assessing how closely the translated text matches a human translation. This metric is particularly useful for tasks where maintaining the original meaning and structure is crucial. ROUGE, or Recall-Oriented Understudy for Gisting Evaluation, is a set of metrics designed for evaluating the quality of summaries. It measures the overlap of n-grams, word sequences, and word pairs between the generated summary and a reference summary. In Python, you can use the ROUGE score library to compute these metrics efficiently. Imagine you're working on an automatic summarization project. ROUGE helps you understand how well your model summarizes the content compared to a human-generated summary, guiding you in improving the model's output. Sentiment analysis is crucial in understanding the emotional tone behind words. For LLMs generating content, evaluating the sentiment ensures the text aligns with the desired emotional impact. Key metrics in sentiment analysis include polarity and subjectivity. Libraries like TextBlob and Vader and Python offer tools to perform sentiment analysis with ease. A practical example would be analyzing customer feedback. Using TextBlob, you can determine the sentiment of each feedback and categorize them into positive, negative, or neutral, helping businesses make informed decisions.
Let's put our knowledge into practice with a real-world example. Suppose we're evaluating a chatbot's responses. We'll use Python to implement precision, recall, F1 score, BLEU, and sentiment analysis. By combining these metrics, we can get a comprehensive view of the chatbot's performance. We'll walk through the code step by step, interpreting each metric's results, and identify areas for improvement. This hands-on approach not only solidifies your understanding but also equips you with the tools to enhance LLM outputs effectively. Interpreting the results of your LLM evaluations is crucial for informed decision-making. Once you have your metrics, align them with your business goals to identify strengths and areas needing improvement. For example, if BLEU scores indicate poor translation quality, you may need to refine your model's training data. Understanding these metrics enables you to make data-driven decisions, ensuring your LLM outputs meet your expectations. Continuous evaluation and iteration are key to maintaining high-quality AI-generated content. Congratulations, you've now mastered the essentials of evaluating LLM outputs using Python metrics. Remember, accurate evaluation is key to ensuring the quality of AI-generated content. I encourage you to apply these skills in your projects and share your experiences in the comments below. Don't forget to like, subscribe, and suggest topics you'd like us to cover next. Let's continue exploring the exciting world of AI together.